What is up, my dudes?
Today we will be talking about matter,
Phases,
and gas laws.
So let's get it started.
Matter is classified as a pure substance or a mixture of substances. A substance has fixed composition and uniform properties throughout the sample. Element and compounds are substances.
A mixture is composed of two or more different substances that may be physically separated. A mixture may be homogeneous or uniform, a solution, or heterogeneous, uneven.
The following are other properties of mixtures.
Substances in a mixture retain their original properties.
They may be separated by their size, polarity, density, boiling and freezing points, and solubility.
And filtration and distillation are processes which can be used to separate mixtures. On the left is an example of distillation.
On the right is an example of filtration.
Bars.
An element is a substance composed of atoms with the same atomic number. It cannot be broken down by chemical change.
A compound is two or more elements that are bonded together. It can only be broken down by chemical changes. Substances that form compounds gain new properties. The ratio of substances in a compound is constant. Okay. A physical change is one that results in the rearrangement of existing particles in a substance. Examples include freezing and boiling.
A chemical change results in the formation of different substances with different properties.
Take note that chemical and physical changes may be endothermic or exothermic.
The three phases of matter are solid, liquid, and gas. Each has its own properties. In chemical reactions, solids are heated to the point where molecules holding bonds together break apart and form a liquid. Breaking bonds absorbs energy, so the change in delta H is positive.
If a liquid freezes, delta H is negative because energy must be released. Remember, a change in energy is equal to mass times the heat of fusion. In which equation does the term heat represent heat of fusion? I'll give you a few moments to think about it. If you chose choice 1, you are correct, because energy was absorbed in breaking bonds to form a solid to a liquid.
Liquids are brought to their boiling points and the bonds holding them together break apart to form a gas. Like heat of fusion, it absorbs energy, so delta H is positive.
The reversal heat of condensation releases energy, so delta H is negative. Energy is equal to the mass times the heat of vaporization.
Specific heat capacity is the amount of heat per mass required to raise the temperature by 1 degree Celsius.
Water has the highest specific heat capacity because the bonds between molecules are very strong, so breaking them apart requires more energy. The equation is energy equal to the specific heat mass times the change in temperature measured in Kelvin.
On the next two slides, you will find graphs of heating curves. You will also find as temperature increases that kinetic energy also increases.
In this second depiction of a heating curve, you can see that water experiences heat of fusion and heat of vaporization as temperature increases. Please note that at phase changes, there are no temperature changes, just energy changes. Now let's talk about kinetic molecular theory. They tell us how gases should behave under ideal conditions.
Gas particles are
random in motion. They collide with the walls of the container and cause pressure to be exerted on the gas.
They are negligible in volume because the gas particles are separated by large distances relative to their small size.
There are no forces of attraction between them.
The collisions are elastic and result in a transfer of energy from one particle to another. There is no net loss.
Average kinetic energy is directly proportional to Kelvin temperature of the gas.
A real gas behaves most like an ideal gas when there is low temperature and high pressure. Check out the following combined gas laws.
Combined gas laws determines the relationship between pressure, temperature, and volume.
Increase in pressure decreases volume.
Increase in temperature increases pressure.
Increase in temperature increases volume.
The combined gas law shows the relationship between all the three variables.
Take a look at the graphs at the bottom of this slide. They may be found on your Regents exam.
With pressure and volume, if the space is reduced inside the container, the frequency of collisions increases.
In terms of volume and temperature, molecules gain kinetic energy as temperature increases, and volume also increases. The following are practice questions. 1. What physical changes are endothermic? If you chose B, melting and evaporating, you are correct.
Number 2, in a laboratory where the air temperature is 22 degrees Celsius, a steel cylinder at 100 degrees Celsius is submerged in a sample of water at 40 degrees Celsius. In this system, heat flows from... If you chose D, the cylinder to the water, and from the water to the air, you are correct. Now time for some more review questions. Stephanie, what causes a gas to exert pressure when confined in a container?
Well, Sephora, collisions against the container produce a force that causes pressure to be exerted by the gas.
And which phase of matter does not have a definite shape, yet the particles will not fill the container?
A gas.
And lastly, in terms of kinetic molecular theory of gases, how can an increase in the temperature of
now
gas
on to heating
confined in a
curves.
rigid
Sephora,
container
what is the
cause
melting
an
point of this
increase in the
substance?
pressure of a gas?
That
Stephanie,
must
I
be when
don't
kinetic
really
energy
know.
increases,
But
pressure also increases.
melting point is also for heat of fusion, right?
Yes.
So I'm going to go with number 2, 55 degrees Celsius.
You are correct.
Our last practice question, guys. We're almost done. Given the heating curve where substance X starts as a solid below its melting point and is heated uniformly, identify a line segment in which the average kinetic energy is increasing.
That must be where the temperature is also increasing. Line segment A, B, C, D, and E, F all show an increase in kinetic energy.